So now we're ready to talk about the binomial probability function. So the binomial probability function gives the probability that there are x sub k successes in a binomial experiment. In other words, it gives the probability that a binomial variable x takes on the value xk, right, or equals x sub k. So here's the formula that we use. The probability that x is equal to x sub k is going to be equal to n factorial divided by xk factorial times n minus xk factorial times p to the xk power times 1 minus p to the n minus xk power, where we have n is the number of trials, and then p is the probability of success. Okay. So using this formula, as long as we know the number of trials and the probability of success, we can construct the probability distribution of a binomial random variable x. Right? So can construct the probability distribution of a binomial random variable. Now let's look at a few examples. Suppose that in my first example, I have n equals 5 and then p equals 0.3, and I want to find the probability that my binomial random variable x equals 3. So if we apply the formula here, it's going to be equal to 5 factorial divided by 3 factorial. Let me write that. Times 5 minus 3 factorial. Okay. Times 0.3 cube. Right, so p to the xk times 1 minus 0.3 to the n minus xk to the 5 minus 3. This means that we're gonna have 5 factorial, which is 120, divided by 3 factorial is 6, times 5 minus 3 factorial is 2 factorial, which is 2. Right? Then 0.3 cube gives you 0.027, and then 1 minus 0.3 to the 5 minus 3, which is to the second power, gives you, this is 0.7 all square. So then we're gonna have 120 divided by 12, that gives you 10, right, times 0.027 times 0.49. And so if you do the math here, you're gonna get 0.132 as your answer. Let's do another example, right? Let's look at a situation where n is equal to 7. P is equal to 0.6. And then we want to find the probability that x is equal to 2. So we want the probability that x is 2. Again, we want to apply the formula, right? We want to have 7 factorial divided by 2 factorial times 7 minus 2 factorial. Then we're going to have 0.6 square, right? And then we're going to have 1 minus 0.6 to the 7 minus 2 power. Okay. So I'm not going to work out the math here too much. You can check the math yourself, right? But the first term here should give you 21. The second factor here should give you 0.36. And then the last factor is 0.4 to the 5th power. So you're going to have 0.01024. And if you punch this into your calculator, you're going to get 0.077 as the probability. So now using the formula is all fine and good, right? You can just plug in the numbers and then do the calculation. But it's very easy to make mistakes, right? So what a lot of people do, and what you can do in this course, is you can use what's called the binomial probability distribution table. So here's a part of the table that is one page of the table. The whole table has been posted on CourseNet, right? So you can go and look it up on there. So let me tell you how to use the table. On the top row here, right, we have the probability of success, P. So we have 0.01, 0.05, 0.1, and so on, right? Then we have n here being the number of trials. So we have the table. In this table, we have probabilities for 2 trials, 3 trials, 4 trials, and so on and so forth. Within each of the within each n, we have values ranging from 0 all the way through n, right? These are the possible values of the binomial random variable. Right? So let's use this table and confirm our calculation from earlier. So earlier we have n of 5, p of 0.3, and then the probability that x is equal to 3 is 0.132. So that's our first example. The second example, we have n of 7, p of 0.6, and so the probability that x is equal to 2 is 0.077. So let's see how we use this table to find these two probabilities. Let me get rid of all of these first. Okay. So for the first case, n is equal to 5. So we want to go to the part of the table where n is 5, right? So it's this part. Now p is 0.3, so we want to look under the column where p is 0.3. So it's going to be this column. Now we restrict our attention to just these values. And then we want to find the probability that x is equal to 3. 3 is right here, right? So if you trace it horizontally, you get a value of 0.132, which is exactly what we got from our calculation. Right? So this one is good. Now let's try the other one. In the other example, we have 7 trials. So we want to go to the part of the table where n is 7. Okay. So it's essentially this part. We have a probability of success of 0.6. So we want to look under the column 0.6. So then we restrict our attention to just this column, right? And then we want to find the probability that x is equal to 2. So 2 is right here. You want to trace it horizontally. Okay. And that gives us a probability of 0.077, which is what we got. So you can use the formula if you want to, or you can use a table whenever you can, right? Whichever way you prefer. Now, what is a weakness of this table? You can tell immediately a weakness of this table, which is that which is the fact that it doesn't give you the probability distribution for all p's, for all probability of success, right? For example, you can ask yourself, right, what if p is equal to 0.33, right? Notice that 0.33 is not in this table. So you cannot use this table to find probability distribution where p is 0.33. So what do? Remember that we have the formula, right? So if we run into a scenario where the table cannot give us the probability distribution that we want, you can plug numbers into the formula and find probability. Okay. So in this video, we looked at the binomial probability function. We looked at how we use that formula to find the probability of a binomial random variable, and then we learned how to use the binomial probability distribution table to find probabilities for a binomial random variable as well.